Hey, geometry class. This is the third time I've tried to record this lecture, so I'm sure I'm tired. It's getting late in the day. Yes, I'm still wearing these clothes. No, I will get out of here. I promise. I will get out of here. This is a special bonus lecture. This is, in fact, the standard that I'm trying to teach you, but it takes a lot of scaffolding. It takes a lot of building things up in order to get this concept. And the concept is, can you build an equation of a line parallel through a point, perpendicular through a point, or through like a perpendicular bisector? That's the big skill, right? And if you're going to go into any kind of engineering, other mathematics, being able to do this is critical. But even if you don't, having this kind of sequential problem solving skills is really important. So what I'm going to do is go through 3 problems. It shouldn't take any more than 45 minutes. I'll see if I can do it under 10. And just remember that these kind of problems take persistence and working everything out. So the first one, what is the equation of the line parallel to this one, y equals negative 2x plus 5, that passes through the point negative 3, negative 1? There's a lot of information here, so let's just piece through it. The first question is, do I want the same slope or a different slope? Well, since my line to B is parallel, I need the same slope. So I look at my equation and I say, oh, okay, the original line has a slope of negative 2. Therefore, the equation of the line parallel to it is also going to have a slope of negative 2. The next question says, or statement, is just build the y equals mx plus b from slope and known point. Here's my slope. Here's the known point. All I need to do is plug this point, negative 3 is the x, negative 1 is the y, into this form. The negative 2 comes from the slope, and then solve for b. And when I do my algebra, you can see, oh, right. Yeah, all so far so good. I subtract 6 from both sides. B is negative 7. Therefore, the equation to this line is y equals negative 2x minus 7. Now, some people may say, could I actually graph this as well? Excuse me. The answer is yes, but you need to be really careful because if you have any kind of funky fractional points, graphing it can be brutal. And so I try to just keep it as clean as I can. So let's just go ahead and do a quick graph here. I'm just going to start with the original, plus 5, 1, 2, 3, 4, 5. And then I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, right? And then I can extend this indefinitely. So this is the original line. Oh, it didn't work. See, that's part of the problem. Let's see, there we go. See if I can do it like that. You know, probably something like that. And again, I might even mess up here, which is not the point. And then if I want to do a line parallel to that, I'm saying I'm going to grab that line, if I can. Will it let me? There it is. Copy it, paste it, and I'm going to just move it over here, and I've already figured it out. And basically what I'm saying, if it goes through this point, negative 3, negative 1, let me just move this to that very point. So I'm going to go over negative 3, 1, 2, 3, negative 1. And therefore, you can see it's parallel. And again, the same slope, down 2, 1, 2 over 1. But trying to figure out that this point right here is negative 7 is tricky. 1, 2, 3, 4, 5. See, it looks like 6. So my line's a little bit off. Solving it algebraically is definitely the way to go. But you can do it graphically if you're really careful. So you did that in under 4 minutes. Question number 2. Can the voice last? That's the question. What is the equation of a line perpendicular to y equals negative 2x plus 5 that passes through the point negative 3, negative 1? Well, again, same or different slope. In this case, I want perpendicular, which means the opposite reciprocal, right? So if the original slope is negative 2, I want an equation with a slope of 1/2. Second thing, I'm going to plug in the known point. Voila! Right? Everything looks pretty familiar. Again, I multiplied the two together. I'm just using negative 3/2 rather than negative 1/2. But when I combine my like terms here, and I add, see there's an error right there. When I add 1/2 to both sides, I'm going to end up with a positive half. And then I need to fix my equation down here. And you'll see this should not be minus 2.5, it should be plus 1/2. And again, the same thing. I could graph this out, but it's really tricky to make sure you get everything just right. And then trying to figure out this y-intercept being a half and not 0 or 1, good luck. You're best off trying to solve it algebraically. Hey, 2 problems in 5 minutes. You're doing great. The third thing I need to go over is, what is the equation of the perpendicular bisector to the points 5, 3, 3, negative 1? No, this one's a little bigger. So what I'm saying is I have a segment that runs between these 2 points. What I need to do is to figure out the slope of that segment. I need to then figure out what the perpendicular slope would be. I need to pass it through the midpoint of those 2, and then I can build my equation. Well, the fact that I could just explain that in 10 seconds means it's really not that bad of a problem. First thing, to find the slope, I use the slope formula, right? y2 minus y1 over x2 minus x1, and you get a slope of 2, which means the slope perpendicular to it is going to be negative 1/2, the opposite reciprocal of 2. All right. Now what do I need to do? I need to find that midpoint. I need to find the point where this thing cuts through, right? Well, if you recall, your midpoint formula is the average of the x-coordinates and the average of the y-coordinates. And that's all I'm doing here. 5x, 3x2 divided by 2, and that's 4. 3 from y1, negative 1 from y2 added together is 2 divided by 2, which is 1. So now I have the actual midpoint. I can plug those values, the slope perpendicular that I need, and this point into it. Solve for b, right? b is 4, and then I can build my equation as y equals negative 1/2 x plus 4. See? Wait a minute. 3 problems in 7 minutes plus an introduction. What, you want me to graph it? No, that's enough. I think you got it good.